All right, boys and girls, this is just going to be another video explaining how to multiply a whole number by a fraction or a fraction times a whole number. And so this video is going to mainly focus in on models and the models that you might see on a test. And so this particular problem is 5 times 4/5. When you see 5 times 4/5, you can look at the picture that's beside it, and you can really just think about what's taking place here. You're looking at 5 groups of 4/5. So the reality behind it is really you're just doing 4/5 plus 4/5 plus 4/5 plus 4/5 plus 4/5, which they've kind of done part of the work for you on the picture. And if you were to do it that way, you could just add up or really kind of skip count by your fours there, and you can get 20/5. Or what your teachers are probably going to want you to do, or at least I know I would want to see this, is I would want you to take 5, write it over 1, which is basically saying you're still doing 5. You're just writing it as a fraction, and then you're timesing it by 4/5. 4/5 obviously is what you're multiplying, and you're thinking, okay, well, every time I have a group of 4/5. You just have it over and over and over again. But if you see this setup to me is a lot easier, and it's a lot quicker, because now that you're in 5th grade, you should be able to multiply pretty easily. So if I multiply across, 5 times 4 is going to give me 20, and then of course 1 times 5 as my denominators are going to give me 5. And then what I'm really looking at here is an improper fraction of 20/5, or a division problem of 20 divided by 5, which is going to give me the answer of 4. So if you really were to put these pictures together, you would get a total of 4 wholes. But it's just a different way of looking at these problems. They're not too difficult. Most kids in 5th grade, when we start teaching this, don't have too many issues with it, but you have to be able to see it with models. All right, so on this particular page, this is one I just drew out. And so I drew out what this problem is showing. I'm making this model. I'm showing that there are 6 groups of 1/3, basically. So I just drew 1/3 in a circle. It's not the prettiest drawing in the world, but if I took a circle and I split it into thirds and I shaded one of them, then I could model this problem by using that picture below. If I wanted to, I could now think about, all right, if I wanted to find an answer, I could basically go and solve it, and I would solve it the same way I did on the previous page. I basically would call this 6 over 1 to keep it 6, and then I would times it by the 1/3 to get 6 over 3, or 6/3. Well, if you have 6/3, 6/3 is really 6 divided by 3. So I'm going to try to squeeze it in here. You really would get the answer of 2, or 2 wholes. All right, this page here just has a model, but what they've done on this model is they've kind of shown it to you 2 different ways. They've split this model up, and I'm going to do some labeling. So basically they're showing fourths here. And so by looking at this, I see a lot of fourths being repeated. But one of the things they've also done is they've taken all these fourths and they've combined them together. And when they combine them together, you actually can see the answer to what the problem could give you. So if you were to try this problem, you would see 1/4 times, and you just would count how many there are. So there's 1, 2, 3, 4, 5, 6, 7. I could simply write this is 1/4 times 7. You could flip it. You could always say this is 7 times 1/4. Either way would be correct. Most of the time, when you see something like this that's already done for you, especially this picture, the picture at the bottom, your answer's sitting right there. And so if you know how to read that model, you can simply walk away going, okay, I see 1 whole, and then I see 3/4, so this answer is definitely going to be 1 3/4. If we want to see it using math, then I would come over and I'll pick one of these expressions. I'll put the 7 over 1, multiply across, get 7/4, and I know that 7/4 really is just 1 whole, 3 extra fourths, and then I would come away with the same answer. So again, multiple ways you can see this. From my experience, especially on STAR test, you're probably going to see more models when it comes to this. They really like to use models. All right, and then this last page here is just another example of what something could look like. So what they did here, and I'm going to kind of scratch out a part of this. So what they did here is they took 3 times 2/3 and they just modeled what that would look like. So they put it into kind of like a fraction strip or fraction bars. They used rectangles here and cut it into thirds, and then they have 2/3 on each one. And so if you were to count the thirds, or excuse me, if you were to count the 2/3 here, so you have a group of 2/3, another group of 2/3, another group of 2/3. Basically, you can just skip count by twos if you wanted to. So you could really say 2, 4, 6. There's really 6 groups of 2/3. And so if you were to really look at this problem again, it's going to turn into a division problem. Ultimately, you're going to have 6 divided by 3, and that would give you 2. And just to show how I'm getting that, I'll rewrite the problem. You could rewrite it as 3/1 times 2/3, and then you just multiply across. 6, or excuse me, 3 times 2 is going to give you 6. 3 times 1 is going to give you 3. 6 divided by 3 is an answer of 2. So multiple ways to do these. Again, be ready for some models. The models usually aren't too tough, but a lot of times that's what they want you to do on tests, is they want you to be able to read and analyze a model.